Hi folks, so today we will talk about the self-sovereign internet. Yeah, yet another SSI. Actually, it's based on the self-sovereign identity principles. So, why it's matter and what it's about. I read about this in a Philip Wednesday blog. Actually, I'm waiting for his book. It's quite great guy in identity space. So somewhere in February it will be the book about the identity architectures and identity systems. So the problem of the internet actually and internet protocols that we currently have, that it was designed completely stateless and it was designed completely without the permission and authentication layer. Yeah, for sure, over the time we built some standards and all other things that somehow extend and solve this problem, but the problem is that they are not enough. So yeah, for sure, we will not touch the part of the Web3 and the storage or storage layer. So actually the blockchains partially trying to solve this problem, or I would say the IPFS tried to solve this problem. But how we could solve the problem that we have the ownership and proper authentication of the users in tools that self-sovereign identity give us. So it's quite a simple concept. A lot of these concepts actually used by the companies that already working in a EOT space and try to solve the problem that you identify devices in a network and create some kind of agents that are cross-connected devices and build the permission layer on top. So the idea is simple, that in internet is the problem that you could hijack the package, change the IP, change anything, and we try to solve this problem with the TLS. But here the idea is quite simple, that we have the DIDs, and DIDs actually represent you could have the DID for your own, or you could have the peer DIDs for every connection with other people that you have. So you have the DID peer, or you have the similar DID methods that you just create the DID for some kind of interaction. So for example, if you want to interact with me, you create the DID pair, we exchange our DIDs with each other, so it's the separate protocol that allows us to do it, and we keep the information about the DID documents in our own co-local space. So it's a quite interesting topic about the DID carry or DID peer. So we will not touch this, but the main idea that for every interaction we have the DIDs, and DIDs will serve us like the IP addresses. So the DID, it's our address that some other people could actually send the data to us, and then we could take the protocol, that transport level protocol or messaging protocol that based on the DIDs. So, and for example, one of the examples of these protocols is the DIDCOM, or if we're talking about the affinity ecosystem, is the DID messages. So, and the DIDs together with the DIDCOM form us the basics that actually allow to exchange the packages and messages fully encrypted with the clear ownership. So we will know the origin, from whom this message came, and we will know to whom this message is addressed, and only the adressat of the message will be able to decrypt the message and read the message. So we have the actually security layer on top, and it's the basics of the self-sovereign internet. So we combine the DIDs together with the DID messaging, and it's these basics allow us to build exchange protocols, or any kind of protocols. For example, we could build the protocols that allows the IoT devices talk to each other, or some support systems talks to IoT devices, or update their software and do all other things. But the messaging and security protocols based on the DIDs instead of the IPs actually give us the possibility to build the application layer protocols, and it's the main idea of the self-sovereign internet, that we have co-local states, we have the DIDs, the DID house and DID com. So it's quite interesting idea. A couple of companies already have it somehow on the custom implementation. I guess that it will open a lot of interesting applications for us. For example, one of the application layer protocol for self-sovereign internet could be the passwordless flows, or some other things that will solve a lot of application problems. And just notice that we're not talking about any kind of blockchains. We are not talking about any kind of systems based on blockchain. This could be achieved by the co-local agents that will store the DID documents peer-to-peer, and will store the messages. So we still need some kind of persistent layer, but this persistent layer could be different from the blockchain. For example, it could be Keramik networks together with the Compose DB, or some other things. It could be the IPFS together with the lead protocol and all other things. So that's quite interesting space, but the idea is simple, that we replace the IP with the DID, we replace the let's say TCP with the something similar to the DID-COM, and we have the new bright internet with the permission layer, that we have the cryptographical proof of the ownership, we have the cryptographical proof of the addressants, and they could freely interchange the messages. And the main idea that you don't have one permanent address, you always have different DIDs for the different interactions, so you somehow form a complex network of the peer-to-peer connections, and it's just mind-blowing. So that's all that I was keen to share with you. Please subscribe to my channel, please share your ideas about the self-sovereign internet, self-sovereign identity, what you are doing in this space. If you want to do more, let me know. I have a lot of interesting things. Let's build the future together, and see you.